Imagine like a passenger jet that instead of trying to avoid turbulence was actually engineered to fly directly into the storm.
Right, to like make its wings structurally stronger or something?
Exactly. I
Yeah.
mean, that sounds completely insane for an airplane, right? We are so conditioned to think that avoiding friction and avoiding failure is the only way to keep a complex machine in the air.
Oh, absolutely.
But today, we are looking at a software ecosystem that does exactly that. We are jumping into an architecture that builds strength not by hiding from chaos, but by actively absorbing it. So, welcome to this deep dive.
It's a really great topic today.
It really is. Today, we're taking on a fascinating mission for you all, looking at a series of writings from May and June of 2026 by Maurizio Rizzari.
Yeah, specifically focusing intensely on the concepts within his flagship piece. The one titled, SYRAG is not about building more tools, it is about building continuity.
Right. And our mission here is to unpack this entire SYRAG ecosystem. We're going to decode why the future of technology isn't really about, flashy new tools or the latest AI hype.
No, it's about building systems and data life cycles that simply do not break when reality actually hits them.
Okay, let's unpack this. Because to really grasp how this ecosystem functions structurally, we have to isolate the specific mindset it is actively rebelling against.
Right, you have to understand the old way first.
Yeah. Rizzari levels a pretty heavy critique at contemporary tech culture, arguing it's just captivated by spectacle and what he calls the dangerous illusion of perfect control.
That phrase, it captures a major vulnerability in how software is traditionally designed. Because from an engineering standpoint, creating a system that functions flawlessly inside a controlled laboratory environment, that's a solved problem.
Yeah, that's the easy part.
Right. When you can dictate the exact inputs,
Yeah.
maintain perfect network stability, and predict every single user action,
Yeah.
you can build a beautiful, seamless application.
But the architecture just assumes a sterile environment.
Exactly.
But once you deploy that application, you are dropping it into an environment that is messy, highly unpredictable, and just fundamentally uncontrolled.
And that is the exact friction point. Traditional systems often just ignore real-world variables until, well, a catastrophic failure forces them to pay attention.
Yeah, until the whole thing crashes.
Right. Think about the specific structural breaking points Rizzari lists, like a critical node suddenly failing, or a network connection being lost.
Or like an underlying software dependency shifting without warning.
Exactly, or even just a background process restarting. Systems built on that illusion of perfect control treat those events as totally bizarre anomalies.
Which they aren't, really.
No, not at all. But when they occur, the system doesn't just register an error. It experiences these cascading failures because the architecture never actually anticipated the anomaly in the first place.
It's kind of less like a robust machine and more like a Jenga tower.
Oh, that's a good way to put it.
Right, like the structure looks incredibly impressive and tall, but the entire thing relies on every single block staying perfectly in place. You pull the wrong dependency at the bottom, or, I don't know, a network blick nudges a block in the middle.
And the entire application collapses.
Exactly. What this architecture proposes is fundamentally different. It's like the difference between building a ship, assuming the ocean will always be as flat as glass, versus building a ship specifically designed to take on water.
Right, like a ship that expects a hurricane.
Yeah. It has sealed compartments, decentralized bilge pumps, a hull designed to flex. It survives the actual ocean, not just some theoretical one.
What's fascinating here is that for SYRAG, resilience isn't a patch you download later. It's not a hot fix. It is the core structure.
It's built right in.
Exactly. It designs for problems instead of pretending they don't exist. You stop trying to keep every single drop of water out, and instead, you engineer the vessel to remain buoyant even when a compartment inevitably floods.
Which shifts the entire paradigm, right? Moving from the philosophical to the practical, how does a system actually absorb a hurricane without sinking?
Well, we have to look under the hood at the SYRAG module manager.
Right. Rizzari details its specific practical operations: verification, packaging, publication, recovery, and synchronization.
Yeah, those 5 mechanisms. They operate continuously to maintain the system state. Verification is like a cryptographic and behavioral check on a module before it does anything.
Okay, got it.
Then packaging and publication govern how that verified code is securely distributed. But the really critical engines for continuity are recovery and synchronization.
How so?
Well, in a traditional system, if a process drops mid-execution, the data state is often corrupted.
Oh, yeah. Totally.
The SYRAG module manager handles this by decoupling the module's function from the overall system state. So if a connection drops, it isolates the failed process. When the node comes back, synchronization kicks in, referencing an immutable log to instantly recover the data without corrupting the surrounding workflow.
Wait, hold on. Moving software modules around securely, verifying file integrity, recovering data from logs. I mean, that sounds like standard IT work.
I get that a lot.
Right. Like my IT department does this every Friday night. What makes this a massive breakthrough for continuity?
That is the crucial distinction to make. Standard IT practices, disaster recovery, all of that is entirely designed to hide errors.
Hide them.
Yeah. Standard IT uses load balancers to mask a failing server. Or it restores from a backup after the crash already happened, just to present a smooth facade to the user. It conceals the fragility.
Ah, okay.
Rizzari actually explores this in another piece titled Two Modules, One Shared Principle, Evolution by Exposing Errors.
Wait, evolution by exposing errors.
Exactly.
Yeah.
Standard IT tries to hide errors, but SYRAG evolves by exposing them. It continuously brings those micro-failures to the surface. It's about absorbing complexity without collapsing into fragility.
I mean, that feels super counterintuitive, though. Evolving by exposing your mistakes.
Think about it like a biological immune system. You don't build a strong immune system by hiding in a sterile bubble. You need exposure to pathogens so your body can recognize and neutralize them in the future.
Right, okay. That makes sense. Think about your own tech stack at work, for everyone listening. When a tool fails, does it gracefully isolate the issue, or does it create a total domino effect of chaos?
Usually the domino effect.
Yeah, like if your payment gateway goes down, does it just queue the transactions, or does it crash your inventory database, which then misfires your marketing emails, and suddenly customer support is drowning in tickets?
Exactly. And the SYRAG module manager is specifically designed to prevent that exact systemic collapse.
Because it expected the failure in the first place.
Right. And, continuity isn't just about keeping software online. It's about protecting the data flowing through it and the rules governing that data.
Here's where it gets really interesting, because we're stepping into the broader ecosystem detailed in Rizzari's other articles. When your system intrinsically doesn't break, you can radically change how you handle things like compliance.
Yes. Unpacking compliance by design. This is huge. In traditional setups, proving your data meets legal standards is a massive reactive chore.
Oh, it's terrible.
Right. You build a product, and 6 months later, external auditors show up to see if you meet ISO 277 NARN or the NIST cybersecurity framework or, FIPS controls.
It's all bolted on after the fact. It operates exactly like the early days of GDPR oversight, where companies were just chasing their own tails, doing manual audits for rules their software wasn't built for.
Exactly. SYRAG abandons that reactive model entirely. It embeds those ISO, NIST, and FIPS controls directly into the operating level. Rizzari calls this three-layer distributed verification.
Okay, wait, let's not breeze past that. What are those 3 layers actually doing mechanically to essentially replace a human auditor?
Okay, mechanically, layer 1 validates the cryptographic integrity of the data module.
Making sure nobody tampered with the file.
Yep. Layer 2 verifies the behavioral routing. It proves the data is only moving between authorized nodes.
Okay, and the third?
The third layer is system-wide policy alignment. It checks those real-time movements against embedded legal frameworks like ISO 27001. If it fails any of those 3 layers, the system literally halts the transaction.
Wow, so compliance isn't a chore anymore.
No, it becomes a continuous, mathematically verifiable state. It essentially makes traditional clipboard-style audits totally obsolete.
That is wild. And that specific capability becomes so vital when we talk about what Rizzari calls the conscious data lifecycle, especially for media companies.
Definitely, where content is literally currency.
Right. Every piece of media needs a verifiable origin, which intersects perfectly with the massive AI conversation dominating the industry right now.
Yes, most organizations are talking about AI completely backward.
How so?
Well, they're evaluating AI purely from the outside. They obsess over the model size, or the output quality, and the speed, but they ignore the internal mechanism.
Right, the data itself.
Exactly. If your underlying data is fragile and unverified, your AI is drinking from a poisoned well. SYRAG argues that data governance begins way before the AI output. You have to establish a conscious data lifecycle first.
Because otherwise, if you can't cryptographically verify where your data came from, feeding it into a massive AI just scales up your existing fragility.
It scales it up at light speed.
Exactly.
If we connect this to the bigger picture, we have the conscious data lifecycle, right?
Yeah.
Then we add digital certification to ensure provenance. And finally, we introduce secure agent coordination through what the architecture calls the agent gateway.
How does that agent gateway work? Like with autonomous digital agents moving around?
When an AI agent needs to move data, it can't just use a basic password. The agent gateway forces it to engage in a continuous cryptographic handshake using those same three-layer distributed verification protocols we just talked about.
Oh, wow. So the agent constantly has to prove its authorization.
Exactly. And when you combine all of this evolving by exposing errors, embedding compliance, governing agents through gateways, you reach a profound conclusion. In the digital age, verifiable trust is the ultimate infrastructure.
Verifiable trust is the ultimate infrastructure. That is a great way to put it.
It really cuts through the noise.
It does. So what does this all mean? We've talked a lot about software, compliance, and agents, but Rizzari's writings ultimately point back to the human beings using these systems.
Always back to the humans.
Right. There's this great quote, "Technology is not only about efficiency, it is also about trust, continuity, and the ability to keep moving when circumstances change."
Which is really about preserving human capital. He talks about this in his May 18th article. By forcing the system to natively handle the chaos, human workers are freed from babysitting fragile technology.
Yeah, engineers shouldn't have to spend their weekends manually patching servers just because one module failed.
Exactly. And it's interesting where Rizzari gets these ideas. He draws insights from unexpected places, like participating in a United Nations informal consultation.
Oh, really? The UN?
Yeah. By observing global networking and human collaboration, he saw that complex human systems can't operate under an illusion of perfect control either. They have to endure friction and negotiate errors to maintain continuity.
So is SYRAG ultimately a philosophy of work, just disguised as software?
I think that's entirely fair to say, yes.
Yeah.
It is fundamentally about creating environments that can endure reality. That's what makes the technology meaningful.
Well, let's distill the takeaways for you listening. SYRG really teaches us that true innovation isn't about hype or chasing this illusion of perfect control.
Not at all.
It's about building continuity by actively exposing errors, embedding compliance by design, and establishing a conscious data lifecycle way before AI even touches your information.
It's a complete paradigm shift.
It really is. And for you listening, whether you manage software, run a media company, or are just trying to organize your own life in a world obsessed with speed, durability is the ultimate superpower.
Absolutely. And this raises an important question.
Oh, what's that?
Well, if our most advanced technology is evolving to embrace its own errors, to expect failure, and to build continuity by absorbing complexity rather than avoiding it, shouldn't we apply that same resilience by design to our human teams?
Oh, wow. That is a great point.
Right. What if the expectation of the perfect employee or a flawless project execution is just as much of a dangerous illusion as perfect control in a tech stack?
If we demand perfection, we just create fragility in our teams. That is incredibly profound. Thank you so much for joining us on this deep dive today. Take that thought into your day, folks, and we'll see you next time.